So what is Windows, by the way?
Well, it's an operating system that goes into your account and tells you how your PC works.
Yeah, and is there any other operating system you guys are familiar with?
Yeah, I've done Linux and Mac as well.
Mm-hmm.
Android, Mac.
Yeah, Android, very good, very good. Macintosh for Apple machines. Android mostly for your cell phones. We had this Android book. My daughter, she's using for her classes. What's that? The notebook sort of thing. Chromebook, yeah, Chromebook. So Google Chrome, I guess, is there, and that's an Android system. But anyway, so operating system is an entity in computers that is managing the resources of the computers, right? So when computers are made, they are hardware entities. So you start with hard drives and RAMs and processor, and then everything is put on what we call a big entity that has those things embedded together called as motherboard, right? So we start with motherboard and we start putting the processor. I mean, now the process is all automated, right? So once that hardware is made, uh, we are not directly dealing with the hardware, right? So we are, just entering some commands, or we are going through some softwares, the programming languages, or even Windows itself is so much good and so much user friendly that we are just clicking some buttons. We are just, pressing some keys on keypads and everything is happening, but it's not that simple. So there is an entity in between that is operating. So that's why it's called as operating system. How it is operating? It's connecting the software things with the hardwares. You ask for some file that is there on the hard drive and you want to work on that, so it brings it into another thing which we call it as the operational memory. So there is this long-term memory called as hard drive, and there is another memory called as RAM, right? So whenever it's processing, it brings the things into that operational memory, the RAM thing, right? So who is doing that? Everything is being done under the surveillance by this operating system. Okay, so Windows is an operating system, and then there was another before Windows called as disk operating system, DOS, right? So when computers started, we had the drives that was actually like disks. If you have a hard drive and got an experience breaking that thing, you would see it has small disk like things like we'd had in the past CD-ROMs, right? So this operating system used to be operated on disks or drives. So we call it as disk operating system, DOS. So that DOS is just a command line. Okay. So earlier when we started computing, somewhere in mid 90s, I remember I was doing my my graduation in pre-medical botany, zoology, and chemistry. After being, missing the medical school, and it was quite a tough time in my life. So the computers they started, and people started doing short courses on computers, right? So when we got interacted with the computers, so they were quite uh, boring, or I won't say uglier, but they were like quite boring. Okay, so we had something like that, and then Windows came out, right? So we just write in this search thing, and that's where I can start teaching you this command line thing, because some of the softwares, if they're working on command line, Windows calls it as command prompt also. So those tools, you can open up a shell. This is a shell. So we just type here CMD. So CMD is command prompt. So it just brings in a small app. So when you open it, it's just a black and white screen. So trust me, when we were doing those short courses on computers, so computers were like this. Okay, You might have seen in the old movies where people used to type those commands on computers. They are black screens or white screens, and uh, large number of lines are being written onto that screen, and something is happening. So good old days, computers were like that. But then when this Windows came out by Microsoft, so Microsoft is the company, so they started thinking of giving users a user-friendly computer that should be more colorful and easier to use. That's why I'm using the term user-friendly. And this thing is called as graphical user interface where user interacts. So whenever a computer opens, it opens into this thing called as desktop. Okay, so that's my desktop. It is Wasim's desktop because I'm using my computer and you are using yours. So the desktop which you are actually seeing is yours, right? And on this we can see these different folders, right? Folders in good old days we used to call them as directories. So there is the one I just made. It's called as online trainings, and within online trainings again there are the folders, right? And within the folders we have we can go back this one for instance. So we have the folders within them. Let me remove that for now because you don't have those things. I just practiced before this class. I do every time when I'm taking these sort of sessions because sometimes it happens that the things they just mess up. They don't run right. So I just wanted you guys to have a folder. I just added this online trainings, and I think we decided to have a folder NGS named as NGS. I'm sorry, I think there is some file that is being opened. So he is, yeah, this one. Let me close it on my other screen. And yeah, now I can just push this thing out and now it's fine. So I just close that. So there is this folder, right, called as NGS. So that is there on my desktop. Okay, so you just create a folder on your desktop, right? And you just do right click here, and then it says new, and then you write folder, and you can write its name, my folder or whatever, and you can just create a folder. And within the folder you can have a folder or you can have the files. So what we have inside this folder are some files. So the basic unit, right, of operation here is a file. So we interact with files, different files like text files, or there is the one that's a Python code. So that's why it's called as py file, and then you have their sizes and their dates when they are modified. You can go into the views and you can change into the large icons and they look like this, and you can go into the medium or you can go with details, right, the way we were seeing that. So I think they are big enough, or maybe if you want medium, or maybe I can go with tiles, or I can go with by the way, I like this thing, the details thing, and where I can see, I can sort them on sizes, or I can sort them on types. So CHR22, it's written FASTA file or FASTA file because this file was saved with an extension. Extension is something that you see there is a dot written there. So this file is a text file because when we saved it, it was mu1.txt. He's not showing the file extension here. Maybe I can, yeah, file name extensions. So now they are shown. So that file is a text file. This one is a text. This one is .py. This one is .pptx. What is that .pptx? It's a PowerPoint file. Okay, and X is after Windows 10, Windows XP, right? So that's why they are abbreviated as X. So XP and later versions of Windows. Before that, they were just PPT or DOC, and now they put this X also. So now the latest Windows versions, the files, if they are made with them, they are with docx, right? So docx means it's a document file, Word file. So when you double click this thing, it will open up with Microsoft Word, right? So it's written here, the type is Microsoft Word. So these are the commands which we're gonna practice or which we're gonna run here. But before we go into that, we will just have a view of command prompt or DOS, disk operating system, right? We were here, so we have those text files. So when you open it, they open up with this text editor. Let me close that and reopen that. Okay, so Dr. Iqbal is back. Thank you, sir. Right, so these files, when you open them, they are opened up by that txt or text file is a text document, so that will open with a text, you know, with a tool that reads the text files like this notepad in Windows and then WordPad in Macs. You can make it bigger. So that is the file that's having a raw read data. um, it starts with at sign, and then you have this ID HW1, and these are some indexes which are written. These are the locations on the flow cell within the sequencer on which this read fragment was sequenced. Remember what was the read fragment? So when you take the DNA and when you break it into small pieces, you call it as fragment. And when this fragment gets sequenced in the sequencer, we call it as a read or a read fragment. And this is a file that has those reads, and normally sequencers, they return the data like this in the form of these text files that has those reads. So those reads are how many? You can go and count these at signs. Sometimes those at signs may be here in the scores also, so maybe we can concatenate with this. So we can go like copy, and what we do is we can do control F, but in real life it's not that simple. So where is this control F? Here control F is something like search. So and then we do control V, and then we can see how many reads we have in this file. This is not smart, but the other variants like uh, this WordPad is smart. So you just search it and it will give you its occurrences, and then you can count how many at signs are here. We just mixed another thing with at HWI. We can go like this also, right? And we can see how many at signs are here. That means how many individual read fragments are here, right? How many reads are here. So in this file, I just selected the top 1000, a small data set for just practice. In real life, you can have like millions of them in one file. So an average file size here is 3 to 4 GBs, gigabases. So for that, you should have a laptop or a desktop or a workstation that should have at least 8 or 16 GBs of RAM. How this thing goes, like in our work, RAM is more important. What is a RAM? As I said before, the memories in computers are of two types. Number one is permanent memory or read-only memory, right? Something which you store on your hard drive or USBs or C or D or E. I'm sorry. So these are your ROMs, okay, read only memory. And then you have RAM. RAM is random access memory. So you access it, randomly. It's not like, every process or everything is loaded into that memory. What we call this thing in our language is operational memory, RAM, random access memory. So in our work, RAM is very important, right? So it's a tunnel, it's a bridge, that is where, normally it happens. We have the 6 rows coming and converging into a bridge that is 2 rows, so that, for a proper flow of traffic, that bridge needs to be expanded. Okay, so if your laptop is a 4 GB gigabases of RAM, normally Windows take a lot of resources, so it takes like 3 to 4 GB. Windows itself, this Windows operating system. So a Windows computer having 4 GB of RAM is nothing. Like my this laptop on which I'm teaching you, that was a 4 GB. So as soon as I started storing big files in it, it choked. So I need to double the RAM. All right. So at least 8 GB is good enough to go if you have only one sample, or if you are processing only one sample. But I believe 16 is better and 32 is an excellent. Right. So this is how we do that. So RAM is an operational memory. So right now I'm teaching you about DOS or about Windows or about Linux, but my brain stored the memories which I recalled yesterday. I went to my village and I recalled so many old things. They got back to me. But if I'm loading each and everything right now in my brain, so probably I might be getting the short circuiting. Okay, within my brain, so I cannot, sometimes it happens, people who are lost or people who are, out of sense, they are talking, the things randomly from here and there. Those memories, they come into your mind, and they interrupt the flow of your thoughts or the flow of your speaking, right? So that memory right now, this my brain's operational memory should have what thing right now in my mind. So it should have anything related to NGS, or anything related to Linux, or anything related to DOS. Okay, but obviously I have my memories from my childhood, or from my school days, or from my university days, so that's stored on the back of my mind, right? So that's the ROM, read only memory, the hard drives, and the external drives, and the USBs, and how many drives you have in your system. In my system, I have partitioned the overall hard drive into C and D and E. People, they advise you not to put your data, or not to put your anything which is important on C. Why? Because C contains the operating system, Windows. Ever wondered what about A and B? Were there any A and B? Because we are starting with C, D, and E. And if I put any external drive here, USB or something, so it will be then F, and then the next one is can be H and I and J and something like that. So what about A and B? The A drive and B drive. So people in my generation can recognize that good old days we had that A drives, the big ones, like the size of a bread, roti, or a naan, right, or a pita bread, or hummus. I think the friends from Middle East are also here. So it was a size hummus, right? So that was the A drive, the external one. So we used to put it into the computers, and then we just remove them and put it into another computer. So in this way, those were actually those data transfer drives. And then there came the B's. The B was the what we used to call it as a floppy. So floppy was small size. It used to fit in our pockets, and sometimes we were asked not to hug each other tight, because that gonna break your floppy drive, because you once you bend it, your data is gone. So that was sensitive. And I remember good old days when those USBs came in the market, and they were issued to all faculty members in ComStats. So people used to have those USBs like lockets in around your necks. So people had ribbons, and they were hanging those USBs around their necks. So that was also you know good old days. Those you having USB was no less than um, you know uh, what do you call that thing which you wear in your neck, in your necklace, right? So necklace, so it was just like that, so we worked on them. So C was then the actual one on which the windows were there, A and B were external, and then the next whichever you get is your D, and then next you get is E. So total this hard drive I have is 250. um, how much is, I think it's, yeah, 3 plus triple one, so that's basically um, 300, right? So slightly more than that, 300 and 350 GB. Okay, so 11 triple one GB is here, 97.4 is here, 200 GB is here. So that is, I partitioned my drive into three sub drives, C, D, and E. So operating system is here, and see it is red marked. So I have overloaded it because I installed Ubuntu, so that Ubuntu is also operating on through this C, and I have installed R or Python or many other things which I used to do in my routine. Even Windows itself is having are using a lot of my resources. So what if I click on here and I go to show more options and then properties? So it can tell me like this drive has the capacity triple one GB and 103 is used, and 7.84 GB is free right now. So it's quite jam packed. So he's warning me that I should free up some space, and I know that most of that space is being utilized by Windows and some of the tools or softwares. Okay, right. So Windows itself is using a huge amount of memory. So that's why we used to work with those black and white screens, that command prompts over here. Things are black and white. Uh, the cost of maintaining colors is heavier. We boys are colorblind, so we use our dresses mostly that are coming from those seven basic colors. I believe mostly our dresses are black and white, and somebody, people, they wear blue, or like my favorite is navy blue. But I guess we boys do not go beyond 2 to 3 colors. But obviously, on the other side, वजूद जन से है कायनात में रंग, so obviously women's are colors of this world, so obviously they, those colors, uh, they have more cost associated with it, right? Okay, so that is just to you know give you a basic idea why we need those black and white screens, why we need Ubuntu, because while you are opening a system like this on Windows, so Windows is coming with this. So many things are automatically loaded onto your memory. So that's, and some of the packages or some of the tools like Microsoft Office or this WhatsApp or, Google Chrome, they are on standby mode. So they are ready. So whenever a user needs them, they will come real quick. So they are also uploaded in the memory. Even this desktop, this colorful desktop where you're just clicking this thing, that has heavier cost associated with it. So when your system starts, it starts from desktop. If you want to know whose desktop is this, obviously it's mine. I'm using my own computer, so my computer's name is Wasim. Yours will be Khoshal, or who else is here, Iqbal, or Nazia, or Saira, or whatever. And then you can click on those folders, and within the folders, these individual units we interact our files, and we covered that these files have their specific types. Okay, file types, and each file type can open with its specific softwares, right? Some of them, like text files, you can open up with Microsoft Word, and you can open up a Word file with text. What is that? The Notepad, the text editor. You can open these two files with either of them, right? So since they are like similar, even this Python code is written like this, so that's also something like a text file, so you can just open it with the notepad. Okay, all right, so here we were seeing a raw data, so that's why it looks like this. So we'll come back to this once we talk about a little bit. Let's have some fun in this command line or command prompt. So right now he's showing me an address here, Let me make it, something like everyone sees that, right? So do you guys see this thing? C colon backslash users backslash Wasim Heather, right? So right now I'm in C, and within that I have different users, right? So I'm in Wasim Heather, and right now I'm on Wasim's desktop, right? So I can check where I am right now because I just minimize that thing, and even in Windows you can check where you are. So it says properties, and when you go to the properties it says you are in C backslash users, then there is this colon sign, then backslash and users and Wasim Other and desktop. So that folder, or in good old days we used to call it as directory. So those folders or directories were stored at specific locations. Even desktop, when it starts from somewhere. It has an address, it has a location. You guys must be familiar with that. So everything before this greater than sign is the address or location from where this cursor is operating. So that blinking light is cursor, right? So it's where that blinking light means that he's waiting for you to give him some command, right? And then he will observe, he will perform that command or do that action which you actually require from him, right? So I want to go to desktop. So I am right now in C users Wasim Heather. I just want to see how many folders I have at this place. The command is directory, right? See, when you go to here, like for example here, so that's just a click. So you are in NGS and you know that thing is present in the desktop, right? So within that PC we are in C, and within that C we have those users, and within the user is Wasim Heather, and within that is desktop, right? And within that is this folder NGS. So that NGS folder is within Wasim Heather user, so within a desktop of Wasim Heather, and that is on in the big entity called as users, and users is their own local disk C, right? So everything here is on disk C. If you want to operate anything that is present on D, you can just click here. The folder is here AKU, and then you can see where this AKU is. So you can just click here, right click and properties, and it says it is in D. So within D, and then there is D colon backslash. So on D, we have this first folder AKU, and within that AKU you can have something else. So that is the data which we did at Han University. So just one folder, I just right click on that and you can see its address. So that is in D AKU RNAC, right? So when once I'm here, I cannot click. So let's suppose my computer is just black and white screen, and I just need to know with the help of these commands. So first command which I can write from here is directory. Directory means folders. So show me which folders are here. So you are in C users and Wasim Heather. Within that, it's desktop or it's documents or downloads or OneDrive or videos, or you can go into any one of them, right? So now I want to go into desktop because my folder is there in the desktop. So in order to do that, the folders in good old days, they used to call them as directories, okay? That dot means the root. So there is a mother or root directory, and then there is the subdirectory, and within that, I mean, that is here he's talking about the users. That is the C. So that dot is for C, that is for user Wasim Heather, and within that is this thing called as desktop, right? So I want to change the directory and I want to go to that desktop thing. I'm wondering how I can, because that C is I think not visible to most of you. So I can do with a command called as cd. So cd, and then you press tab, so he will start giving you different options. Though I have seen that option up there. So if I just type D, it gives me desktop, and you click again this tab key and it gives you the option documents or downloads, right? So I just type cd, and I press this thing. CD means change directory, change directory. Okay, so here is the hierarchy of those directories. So who is the basic, or the mother of those directories? C, right? So that is the biggest folder, a drive, so on which everything is residing. Okay, if you write the command cd dot dot, you can go back one step backwards, right? Since we were here in desktops, and when command prompt starts, if this command prompt belongs to user Wasim Heather, because I logged in into this system as Wasim Heather, right? And you have your own system, so I can even do cd and then space dot dot, and I can go one step back. So right now I'm in C. So within C, if I want to see which directories I have, there are Intel and program files and users. So I want to go into users. So again, I do cd and users users, enter. Again, I type directory. So within users, it has public and Wasim Heather. So only two user accounts are here. One is public, one is Wasim Heather. So where you want to go? CLS is clear screen, set the duster. So if you want to just remove all those things, and you want those that cursor to be up here, maybe I can just change the properties of command prompt and make it bigger. I think on your systems probably this control plus plus gonna work. So I just need to figure out, maybe this lecture was not all about this command prompt or DOS or disk operating system, but I just let you know that within Windows we have a space, or this thing is called as a shell, where you can work on command line or command prompt, where what happens is you run a tool by not by clicking or dragging, or pressing some keys, but here you are running the tool with commands, right? Writing the commands. Why we prefer doing the things on command line or command prompt? Windows is expensive, so anything you want to deal here in Windows, right? With first open up a tool called as Microsoft Word, so that has a cost associated with it, and you need to that whole big file, you need to open this and you need to keep it open. Though I'm working on this just one line of this file, but suppose this file has million lines, so that whole file need to be opened. So again, that is heavy on computer resources, so that's why people prefer doing the things on Linux or on this command prompt thing. Okay, all right, so cd, and then what you do is theme header, you just type w, and then I press tab, so it straight away came up and I'm here, right? How I opened up this command prompt thing, let me close that. People who have joined late, I just write cmd. So CMD means command prompt. It's written here also. What is command prompt? You can, the latest versions of this Windows can open up a web browser, and then you can have that help file here. So what is a command prompt and what is that? So you can go through these notes, and yeah, videos are there, and so that descriptions are there. So I just need this thing, this app. So it opens. When it opens, it opens up into which place? It opens up within C, and then within C users, and within that which user? Wasim Heather. I just want to see what I have in here. So two things: where I am in C users Wasim Heather, and what's around me? Directory. The command is directory. Okay, so that has desktop, that has documents, that has downloads, that has rest of the things. So how to change a directory? How can I go to desktop? The command is cd space d. You can write a small letter d, and still it's okay with that. Previous versions it was case sensitive, so not doing that. So even in the, I think in Linux, we need to, the previous versions for sure, we used to enter the capital letter D. So when you write that D and press tab, so he's giving us three options. So either you just stop here CD and just accept that, or you click the tab multiple times, the tab key on your keypad, okay, and it will give us Or what you can do is you can add another E here, another letter here. Now these are two letters, and when you press tab, so it uniquely identifies desktop. This thing where I'm using those combination of letters is called as regular expression in our language. In bioinformatics or computing, we call this thing as regular expression, regular expression. We'll explain these things later on. So now you enter into the desktop, okay? And then again you want to see which directories you have on the desktop. So you have NGS shortcut links. Some of them are hidden directories which are not shown here. Some of the viruses they are created, but this command line captures everything, okay? This thing is, I think, a little bit blur. So what we can do is show more, and then I think what we can do from here is um, we can just go to, for example, desktop here here just one step backwards. You can do that here also, and now you are in desktop, and you can just go to view, and then you can go show and file extensions, hidden files. So hidden files will also be shown here, but that shortcut is automatically created, so I think it's not hidden. But sometimes if you see a folder that's blur, uh, that is hidden folder, and normal routine, you won't see that unless you just enable this thing, right? So right now I'm in desktops, and within desktop the folder on which I want to work is NGS, so I can go like NGS, then I do directory, and within NGS I can see its contents. So the folders or directories are given with the word directory, but here dir is not written. If dir is not written, it's a file, okay? And this is the file size, so that is 25.0, 25 to 25,068 bases, are 25 kilobases to 25 KB. That's the file size. So you can just correspond from here, right? So this one is just 25 KB, this file, okay? And rest of them you can also correspond them. But here my objective was not to teach you this command line or command prompt. I sent you one document, so that says top 10 Linux commands, right? DOS commands, or top 20 commands. You can just look into them, and you can just practice them. So like CD, there is also MD. MD means make directory. For example, I just want to create a folder within that. So that is something like, I create a folder Sadia within that, right? And I do just directory, and within that it has created a folder, and even time is written on 4/11/2024. We created a folder 6:38 p.m. pay directory, and its name as Sadia, right? So, and even you can remove directory with the function RM. I think sometimes I mess up the commands because some of the commands are coming from Linux, and some are coming from Ubuntu or DOS, so they are sometimes mix or interfere with each other. But I can just open up that document which I had, top 10 DOS commands. You
Excuse me,
can just
sir.
read it, read it.
If we if we open up a folder, it's like opening up folder like we use in the user-friendly interface, right? So what if we have opened up a wrong folder here? So we have to go back. So what kind of
Yeah,
command we have to give that?
everything you need to do is with the command. So I just want to delete that
Let's say
folder.
we open desktop and now we want to go to like download. So we have to exit the desktop and then go to downloads, right?
See, so you can step down from, it's, this thing is just a one-way traffic. So yeah, so wherever you are getting a fork, you need to go back, पिछले चौक पे आपने वापस जाना है, और फिर then you need to take the other route. So yeah, that's what it is. Okay, I just remove this folder Sadia, so the command is directory, and then it's still there. So what is the command to remove a folder? Directory delete is, I think, for file, I think rmdir or rm. So command is rm. Oh, not rm is in Linux. I think RMDIR, remove directory. So that's yeah, forgetting that because we took that course long ago. Up arrow key can repeat the previous command, so I can just do directory and now it's gone. So RMDIR is remove directory. Okay, MD is make directory, but good old days what we learned was MKDIR. So now I think in the latest notes, in these top 10 commands, I have seen the word MD and it worked. MD means make directory. CD means change directory. So mkdir, for example, I want to create another directory, Wasim, and that directory will be created. And rmdir is remove directory named as Wasim, so that directory will be removed. So just to let you know that this command line or command prompt is there on Windows. So sometimes, maybe not now, because most of the community is not using, is not, encouraging people to use Windows machines. Reason can be because in Windows everything is paid, right? So even if you want a proper licensed Windows, you need to pay for it. You want antivirus, you need to pay for it. You need to have a tool like SPSS, the licensed proper, or SAS, or anything like that. So all those tools are paid. Okay, so you have to pay for it. But there came this huge community with the thought of doing the things for free, what we used to call them as open source. So open source is where people are preparing these tools and they are distributing them to the community for the good, and they are doing it for free. I mean, they are really really great people of God. They are creating these tools and spreading them for free, and it's a huge community up there where people are utilizing those tools, and sometimes people give suggestions to the developers, and then those developers they improve them, and if there is some bugs, so those bugs are removed. So in this way, that open source community is a wonderful thing. There is a consortium, a combined effort called as GNU. So GNU is what? It's a consortium, a combined effort where people are developing those open source tools or software. So Linux is absolutely free. R is absolutely free. Python is absolutely free. Okay, you don't need to pay for it. All what you need to do is just learn and practice some commands. Trust me, even this whole NGS course does not have commands, I guess more than 10 commands. So we will just go with pretty basic and very very important commands. But if you are later on at some stages you become a programming geek, or you are a bioinformatician or NGS expert or a proteomic person and you love this thing, and then you can have like you don't need to even remember the command. So every time you are given those documents to follow a document like this, very well documented by us, myself and my team, my students. This first part, earlier when we started Linux, uh, we had been going through evolution of various ways of doing Linux on our Windows machine. When we landed at USA, there was a course on one thing that were told to us, especially by our teachers in computer sciences, that you should throw away these machines and you just install Linux on it and work with the Linux environment. So most of us then bought those Apple machines. So there was one course, Linux and Perl. Before Python, there was another language which we used to do early 2000 years. And that's where when I started teaching bioinformatics at ComScience and started my doctorate in 2009. So over there, this Perl was very, very famous, or very, very, very important for a bioinformatics person to know, right? But when this NGS came out, then another language, which is actually a statistical programming language, R, emerged. So mostly our tools are in R, and obviously in a Linux environment, the operating system should be Linux, where we run those tools, and then later on analysis we might use R or Python, another very very important and user friendly language. So when you open up this Ubuntu, I think everybody has installed Ubuntu, you can just go and write in this search space Ubuntu. I am not going spending more time on DOS. You can just go and do that. And somewhere in your life, if you observe any tool that is operating with DOS, or that is, for that you need to run a command on DOS. This is as simple as that. You just need to go there, and or you just Google, and those commands will be there. So this one is Ubuntu 22.4, 22.04.5 LTS light version, and it's an app here. So after Windows 10 and onwards, oh yeah, I was telling you how we were doing Linux on our window machine. So initially we started with one thing. We used to put that CD within our Linux, within our Windows machines. We had CD-ROMs at that time. So now the latest laptops, I don't see CD-ROMs anymore. CDs were then replaced by DVDs because the people started watching movies on that, or songs on that, videos on that. So that DVD has a better quality than CD. Obviously CD has a better quality than those analog cassettes. In our times we have audio cassettes and video cassettes, and then uh, we have seen the transition into the CDs and DVDs, and now USBs. And obviously when YouTube came out, you don't even need the USBs, right? So that's the wonderful thing which happened. So similar things happened in our field. So realizing that since people were quitting Windows, or Windows machine or Microsoft product, they provided this app like a app on your mobile phone, Ubuntu as an app. So we actually did with CDs. We had the dual boot of systems with dual boot or dual operating systems, where we had the Windows as well as the Linux. So you close the system, and then when you open it, when you restart and press one key, I guess F11, I think, and then it will then give you an option to either boot from Windows or boot from Linux, right? And you choose Linux, and then you work with that, and then you close your system. Obviously the files are stored on C or D or E, or you can access those within Linux environment, and those files are, then you can use Windows, and R was equally good on Windows and Linux. So but to run the tools like the tools for genome assemblies or RNA-seq, you need to have the systems in Linux. Um, I'm having azans here, so let me observe one of them, and then in the meanwhile you can take a pause and review your notes, and any questions you may just ask. Just give me 5 minutes. Okay, so let's those of you who have not installed Ubuntu, you just go here on this, in the search you write Microsoft Store here, just write micro and then it will give you the option. It's another app, so that's there with the Windows 10 or 11 or yeah. So right now I think mine is Windows 11. Okay. So when once you go here, you can just write Ubuntu, and within that it's 22.04.3 LTS or 20.04.3. You can try both. So first try this 22 variant, and then you can go with that 20 variant, and then since I've already installed it, I just open it from here, right? So there is this shell that's coming, so it's starting, so I can just wait. And yeah, so it says root at Wasim colon, and then it has this um, colon and this tilde sign, where you have that in Urdu language, that tilde or tilde, mad, alif mad a, and then meme, and that makes or mango. So that tilde sign or tilde sign is there. I'm wondering, I think it's there in Arabic also, right? So that symbol, and then you have this hash sign, and then the cursor is blinking. When the cursor is blinking, that means you can write a command here. Here we will not issue the same command. uh, we can check where we are. So the command is pwd, present working directory. So it says you are sitting on root. I did not create like you guys. I think Sadia taught you to create. I'm seeing that in the notes. So it says you uh, just give me a. So Windows 10 above, go to start menu, installing, open and provide name and password. Actually, I skipped that step. So if you have opened up, it will say NGS at something in on your laptops. Don't mind. Rest of the things are the same. So in my case, I since installed it on root. So it says root at Wasim. So the root directory, okay, the the mother of all, where from where I'm starting. This there is a tree that is formed here, right? So that tree starts with the root, and then we have the trunk, and then we have the branches and sub branches, and then individual files are like leaves on, the plant terminates at the leaves, okay, but the branches, they keep on going. So what is the final operational unit where the plant ends is leaves. So here those operational units are the leaves, are individual files. So those files are within the folders, that is the branches or sub branches, and then you have those main branches, and then you have the trunk, and then you have the root. So that hierarchy is followed. So that's why this word root is written here. So directories or folders are also like the grandparent, or the child, and the grandchild and something like that. So that hierarchy is there within those folders also. Okay, you can have a folder within a folder. So you have a bag. Okay, Sadia left her bag here, so she has within that another small uh, bag where she's putting anything like I think the money or jewelry or cards or anything. What do you call that thing as wallet, right? So those bags within the bags, and within bags, these folders are your bags, and within the folders you have the subfolders. So PWD is present working directory. Okay, so that means where I am right now. He says you are in root. I want to say where I can go from here. So I can do ls, where my files are. The files are on desktop. So when I do ls, shows me nothing, but for sure, right now I'm on root and I'm on Linux, but nothing is accessible to me, neither C nor D nor desktop or anything, right? Because here I'm using this computer on an entirely different operating system. So that operating system need to have access to C. Okay, so for that, first of all, I need to mount that C drive on the system, or access that C drive onto the system. So I can do cd, and then I can go with slash, and then I can go with Java or fonts or anything, but I want to go with cd slash slash and mnt. Just slash. I need to update or upgrade my system, so that will take a little bit time. Though I did that before, but in your systems, if you have access to uh, yeah, forward slash. So within that, there is a folder that should be here, MNT. So that MNT is where uh, just write MNT, and within that is your C, D, E, and WSL. So C and D and E. WSL is actually this operating system, Linux. We call it as WSL. So it does not have access to C drive. So anything which on which you want to work is there on C drive. So you just need to go, and that CD is within this called this directory called as MNT, right? So you do CD MNT. Either you can go stepwise. That's what we do. And again, you can just type here ls. I don't know this ls. Yeah, ls command now is working. So it says, the previous version, DOS, in DOS, the command was the dir directory, and here is ls. Ls mean list directories, list folders, okay? So, or even files also. If some file is here, it will also be shown. So the command is ls. So if you open up this document, those commands are there. List files and directories. Pwd is present working directory where you are right now. When you open up this Ubuntu, where it opens, in my case it opens on root, but you guys might be smarter because I guess Sadia during the installations might have told you to create uh, uh, name, a username and a password, right? So that's, I think, where you can play safe. While you're working on root, you might interrupt with these files like this one, especially USR, or you know USR, or there is another one that is very important, dev, right? So if you interfere with them, and that might interrupt your operating system, right? So then you need to probably reinstall your Windows. So that's dangerous. So people advise you to create your own user accounts and don't do the things at the root, okay? Because leave that for the system, right? Okay. So here
Sir,
we please, yes,
sir,
please.
if you give the command for cd and there is no directory showing, why is that?
CD, and then you press tab. After CD you are pressing tab. At first place you won't see anything, so you just write CD and then MNT, right? Or just put this dash thing and press this tab. You are seeing anything?
Okay, sir, let me try.
CD space forward slash and then MNT. The difference between Ubuntu and Unix is there in Mac. So if you people have Mac or Apple machines, Macintosh is the operating system. So within that, in the search bar, you just write um, terminal. So that will give you a terminal or a shell similar to this Ubuntu. It's not Linux, it's Unix. So originally it started as Unix, and then Linux is also the same flavor. I mean, the other flavor of the same thing, right? So the people in Unix, though over there, those slashes are backslashes here. So that's the difference. In Windows machines it's forward slashes, and in Linux those slashes are backslashes, okay? In Unix, within the Apple machines, the Macs, etc. So we just try. Did it work for you? uh,
Sir, these commands are
these commands are, so these ones are down there, I think.
Sir,
Just
if you press, when I press the tab after cd, it shows something but it doesn't let me write mnt.
you
It
just write forward slash and press tab again,
okay.
right? Yeah. So I hope that would work. So that's why I'm a bit slow, and this session will be accompanied by multiple sessions once you are just comfortable with Linux, and then we will do the actual fun. So cd space, I can go back. So I do dot dot, right, and you do it's giving me different options when you press tab. So it's giving me one option called as MNT. So I can just do MNT and enter, and now I'm in MNT. And again I do PWD. So within PWD he's telling me that yeah, so you are in MNT, but he's not showing you those the access to those files. I don't know why they kept it hidden. So I do CD and then I do C. So I do it in just one step also, right? So I can do ls. So within ls it says that you can go to users and you can go to windows, or you can go to, you can go with the program files or system files or OneDrive, but I just wanted to go to users. So command is big U, capital U. Go, and now I entered into users, and within that users I again keep on typing up arrow key and ls. So it says within users is all users, default users, Wasim header. I just want to go to Wasim header, so the command is here, and right now I'm in Wasim header. Up arrow key, the command repeats, and I want to just list the file and directory. So within Wasim header is this thing called as desktop. So I just want to go in his desktop. I can do CLS. CLS means clear screen. So I can, oh, I'm sorry. Here the command is clear screen, or CLS was in DOS. So here it's little bit different, clear. So our control L. So if you do control S, L, press control and then L, keep pressing control key, or you can just write clear. In this way you can just apply the duster on this on this blackboard. So it's white chalk on blackboard. I just cleaning that like we used to do in our schools. The command is cd, and then I want to go on to this e, another e with it. So if I just press option desktop documents download, then you just plug in a small letter e in it. So it's now in desktop. Again, up arrow key, ls, not clear, ls, not cls. Right, so that is where he's showing me different options. So it says there is a folder NGS. I just want to go into that folder. So CD space NGS. I just type N and then press tab key. If you are pressing the tab key and he is giving you some advice or given options, so in that case you are going on the right path. Okay. If I just do, for example, CD and again I'm doing N and pressing, nothing happens. So that means I don't have any folder NGS within NGS, or yeah, there is no such folder. Okay. All right. So I went stepwise from the top step to the bottom, right? And I keep on taking the decisions that where I want to go. You are coming into your campus, and then you know the building, and within the building you know where your class is, which room you want to go. So every time you need to take a decision that where I should go. Okay, so you need to go stepwise. That whole thing is the complete address. So we are in NGS, that is there on desktop. Whose desktop? Wasim Heather's desktop, and he is a user. He's among those one of one of among those 2 to 3 users that are there on this machine, and that is there on its C drive, and MNT is the place where C drive is present. So Linux cannot directly access to C drive, so you need to just put that MNT thing, and then in this way stepwise you can reach up till here. If I do cd space dot dot, that means I can and enter, so I can go and one step backwards. Again, up arrow key, that will repeat cd dot dot. Again you can go back one step. Again you can go back one step, cd dot dot. Or if you write cd space tilde, you press shift and then you press, where is tilde or tilde, there is this key on extreme left of the second row. So on the keypad is the second row, top row is escape, so it's beneath that, or The next key to it is 1 and then there is 2. So behind 1 where it says I think it's a dot here, so if I just press simply this dot, so it is the no, not dotted, I think it's just a quote sign here. So if I press shift with the same key, now it will write this tilde or tiled, some people write it tilde or tiled, so that symbol. And when you do that cd space tilde, it will go back to root from where it started, and then you can start all over again. But I can do this thing in just one step, so I can do E and then I can do like M and N. It's not happening, so I just right, and then within MNT I can press, I know I have E in it, and then it puts another dash, and I can go to user, so I can put a U and press tab, and within that it's Wasim header I know, and within that it's NGS I know. So I can do that in just one step. Okay, right? So I can take a direct flight, but I should have the address so I can go that. So it's a direct flight, or you can go stepwise from here to there and there to there and so on. Okay, so wherever you are comfortable. So first I would like everybody to open up your shells or your Linux shells and start writing those commands. Everybody got access to your laptops? Are you guys practicing these things on your laptops? Were you successful in going into C and then desktop and then within that folder? Were you able to create a folder called as NGS here? Right. So this NGS folder, and within that these files are copied. Everybody has them. Yeah. Anyone? So we have 15 people here, so I hope everyone is doing that. So if anyone having any difficulty,
Yes, sir, we
just
have these files.
very good, and you are practicing that, you are comfortable, right? I can
Yes,
ask
sir.
you to share your screens, and then I can see that. Sometimes you ask the students to share the screens and you can see only a pillow or a chair sitting there. They're not around, and maybe sometimes they ask their younger siblings to sit in. So we had these online classes on this MS
Yes,
Teams
sir.
during COVID days, but I know that you guys are really serious and quite professional. Yes, ma'am.
Sir, can you please tell me why we use MNT command? MNT.
This see, while originally this computer belongs to Windows, okay, and Windows has C in its access, whereas while
Yes, sir.
we are launching a parallel operating system to get access to those files, that C is not directly accessible to Linux or Ubuntu. Okay, so that's
Okay,
why
sir.
there's
Okay,
another
sir.
entity called as MNT. Ever heard of mounting? Sometimes you put a USB on your system, and that USB is
Yes,
coming
sir.
from Mac, or that USB is coming from Linux machine, and it's not being accessible on your system, on your Windows machine. Then you take it to your IT person, and IT person say, "Oh, it's not being mounted, so let me mount that." So then they go inside
Okay,
the
sir.
DOS thing and
I
mount that.
get it.
Something you need to do here, something additional or something extra, because uh, you are doing the things. So now you got the access to the desktop or the access to that folder. So anything or any command you will issue, and anything you will happen, any file you will create, or any file you will delete will be created here. So for example, if I just want to create a folder, so I can, what is the command? Yeah, I think works here. So I just create a folder here, dir, and then I can go back here. All right, so it works. So within NGS, you see there is a folder created was seen, right? So I'm sitting in Linux, but anything is, so Linux is also accessing or approaching those files, and similarly, I can remove that. So command is rmdir. So those DOS commands are exactly working like that. Okay, in Windows, sorry, in Linux. DOS is the father of all operating systems, disk operating system. Windows derives its origin from that. Linux came out from that. So originally it was DOS, disk operating system, right? That black shells, that black screen which you guys have seen that. Over here again, this Ubuntu is also a black screen like this, right? Okay, so let's start doing some fun on this NGS data. Let me show you these files here first in Windows, and then I'll teach you what is the advantage of seeing these things in Linux. So for example, I was just counting these @signs. I can do that real quick in Linux. Okay. This thing is called as shell programming or shell scripting. So that thing is a shell. Okay. I just want to see how many files are here. The command is ls. So we have at underscore transcripts.txt. We have Linux commands. It's .docx. That means the Word document. Online trainings underscore ngs.pptx. So that's a PowerPoint file. Chromosome 22.fasta. That's a fasta file. Get counts underscore updated.py is a Python script, and mu1.txt is something like a text file, and then there is another version he has created from the same file. I guess duplicated that. Maybe I can see a virus here, but in real life here on that folder thing, I think I'm not being able to see that thing. Okay, so Linux actually captures those hidden files which are just created by chance. This is for sure a virus here, right? So I can do show and hidden files even if it's not shown here, though the hidden files are shown, right? So that is one instance he has created. It's just duplicated that. So that means somehow my laptop is being infected. All
Excuse me,
right,
sir.
so yes, please.
Sir, I'm able to go till my e-disk,
Mhm.
but I'm unable to open the NGS camp folder. So you have to write CD and space and that name every time we go into the subfolder?
You can access, that's what you are asking. So you say,
Yes. So every time we open a folder and then another folder, so you have to give a command of CD space and that name.
suppose I'm sitting here at the desktop and I want to see the contents which I have in this folder NGS. So I can go like ls and then I can write NGS here. So I can access this file like, I'm sorry, what was the name? And I can see, or even one step above, I can see what's going on, or I can access that. For example, if I just want to open up a file named as mu1.txt while I'm sitting into the parent folder, not the actual folder NGS, I can do that, right? So there is a command called as, even to open up a file that is this mu1.txt, I can just go simply write a file name, or there's a command called as nano. So nano is a text editor that will open up the word files. So I can see nano and within NGS, nano over NGS on mu1.txt. So I can open up that file here. Okay. Um, in nano you can edit the file. So good old days you used to create the files with nano. You used to create the letters or applications with nanos before Windows came out, and obviously Microsoft Office came out. We had something similar to Microsoft Office in good old days. We can do escape, control X. So those keys are here. If you are adding something here, you can just save it. So you just exit. For example, let me go back to NGS, and I just want to create a file with nano. Is just something like, I name it as you know my file. So I create a file, my file, right? And .txt, since it's a text file, even if I don't write it, nano will take it. And this is my file, and you just close that thing. So you do control X. So since you have added, or you have written something here, so you would say Would you like to save this thing? So I would say y means yes, right? And what was that? So cancel is control C. I go back, so I can go like control X and save buffer, and I can go here and write y, and yeah, and then I press enter, and then this file is saved. Okay, so I do ls, so it says my file.txt I created. You can open up that file again with nano, and you can write my file. That file is here. Control X did nothing, so he won't ask you to save it. So this is how we used to do that. Achha, those files are really big, like this mu1.txt is really big, and rest of them. So Linux gives you an option to see the top few lines of a file. So command is head over mu, just write m or mu and press tab, so it will open up these things for here, right? So this top few lines will be shown. Clear screen, the command is clear, so we do clear and you will come back. Okay, you just want to see the bottom few lines, so that means if there is a head, there should be a tail also. So tail over mu1.txt will give us the last few lines. You want to know how many of those short read fragments are here. So that's just a file that gives you that sequencer gives you an output. So here is this read that has an ID here, and then the sequences. So sequence is going like N C G T G A C T T. N means any nucleotide, so we don't like N's, by the way, but since this is just the first read fragment, so we are okay with that. So let him settle down. And again, in the second read fragment, there is also an N, so it's okay. These are just first two try balls. And then we have that C, and then we have this add with plus sign, the same ID repeats. This thing, this CGATGT is the adapter sequence. So if that adapter sequence exists, Control C F, and I can just paste it. If it exists somewhere in the actual read fragment, so that is where we can say there is an adapter contamination, but it is there in this header line. Now the modern day sequencers are just that ID, that's enough. They don't put these things. /1 means single end reads. If you have the same ID with /2, so that means the paired end reads. We covered that. So sometimes we take those large chunks of the DNA and we take only their ends in a shape of pairs. So one is forward read fragment and one is this reverse read. So forward read is represented by the same ID /1, and reverse is represented by the same ID /2. Okay, and this ID repeat thing is also no more in the latest sequencers, because obviously you have to repeat this thing for millions of times, because in one sample you will get millions of those reads or read fragments. So if you are repeating the same thing, obviously you are increasing your file size. And then after this plus sign and ID repetition, that B thing down there is their qual scores or quality scores. So B means in Illumina, B means a score of I think 66. 66 is not the actual score. The ASCII value for this big letter B is 66. We can just double check here. So for example, I just need to get my Chrome and just write here the ASCII value. I can go from character to ASCII. I think there is an ASCII calculator, so that can you can use that. So B is 66, so it's there, right? So 66 means, since we added 64 as an offset to it, that was there in the previous lecture. So the actual score is 2. So 2 is really bad score. Okay, so B means bad. Read fragment 2 is also bad. So again, it's a tribal. So first 2 or 3 reads are, we're okay with that. But you see that each record has 4 lines, right? The first line is ID, second line is the actual sequence, plus sign and ID repeats, and the, I'm sorry, up till here. This fourth line is their quality score. So sequence plus quality, both of them are together in one file. So that's why this format is called as Fastqc. There was another format also. We just shared this file with you. Let me open that thing. So that's 80 transcripts. So that has the greater than sign, and this transcript are gene ID and then the sequence. Again, a hook or a greater than sign, gene ID, and a sequence. So that format is called as FASTA or FASTA format. Why FASTA or FASTA format? Because initially it was called as FASTA because there was a tool called as Fast Aligner. So we used to align our map sequences with this tool. That is the sequence alignment. Sequence alignment is like you can take two sequences or you can take more than two. If you take two, we call it as pairwise sequence alignment. If you take more than two, it's multiple sequence alignment. So while you are aligning the sequences, there was that tool came out. The first one, its name was FASTA, faster alignment or fast alignments. And then later on, people started calling as FASTA format, FASTA format. So format is something that you need to write that thing and give it to the tool because computer does not has the eyes. So it's like something or some entity who's having vision impairment. Okay, so how somebody would read a text if he does not have the eyes? So you see there are the special books written. What are the name of those books for the visually impaired persons? Braille. Brailles, right? Braille. Okay, you can just Google Braille. So the special books which somebody. So here for the computer, that special character is this hook, that greater than sign. So wherever computer sees a greater than sign, or it feels a greater than sign, right? Then it realizes that a new gene is coming here. So if you can just somehow count those greater than sign, you can just check how many genes are there in this big file, right? We can do that in Linux real quick. So there is a command called as grep. So grep means get regular expression. Let me clear my screen. You follow? You can see my commands here. How can I make that thing bigger, that shell thing bigger? यहाँ पे राइट में जाके नहीं, राइट कमांड से तो जो चीज कॉपी टॉप टॉप लेफ्ट कॉर्नर पे टॉप लेफ्ट कॉर्नर पे हाँ एडिट एडिट स्क्रॉल properties, right? So properties में I'm sorry, let me make it bigger. Buffer size, buffer हाँ large कर लेते हैं. Cursor size नहीं, cursor size ही हमें font is maybe 20 कर लेते हैं, ठीक है? हाँ, bigger भी क्या और करूँ? और करें, क्योंकि अभी छोटा है, अभी भी आप खुश नहीं हैं? Properties, so we can go like 24, right? So big one. Again, clear screen is clear here at Control L. So Control L is clear screen. Let me take that thing out from here. Risha की नमाज का scene तो नहीं हुआ है? Right, so you guys follow? Now the cursor is blinking. And I can just see where I am right now. My command is pwd. Anytime you can check. So you are in C users Wasim other desktop and GS, and your files which you have here are mu1.txt and myfile.txt. You can even remove a file myfile.txt. Even you can copy the contents of one file to another. The command is cp. All those commands are here. You can just practice them, and then we can go and reach to our target, that is to work with this NGS data analysis, and those are the commands that just we need to run. They are shown in that yellow thing, right? So every lecture I will cover the theory part and then this hands-on part and then explain the outputs, and then you're gonna enjoy that, provided you have Linux with you and you practice ahead of time. You have 24 hours, 22 hours before you come for the next lecture after this lecture, and please come uh, ready with the practice session, and then you will enjoy the new sessions. So the command is I want to see what I have in this file. For example, 80 transcripts underscore is not so because you did not give any command. No, I just want to just type file name and just tell them what's gonna happen here. So I do file a command here, so he says command not found. See, so anything, you cannot open up a file directly, but you can open up with nano or head or tail. So I can go with head, and then now I write 80 and he's just fine. So he just gave me the first record, or first two genes, totally I guess 5 to 6 lines he's giving me. I can go with tail, so tail with 80 underscore transcripts.txt, the bottom few lines. Again, control L is the clear screen. I just want to see how many genes are there, or how many FASTA records are here in FASTA file. The command is grep, and then within quotes you can write, or single quotes even, then sign and 80 underscore transcript.txt. He will simply get them and print them here. Okay, suppose your professor asks you to extract the gene IDs from a big file, and just give me the gene IDs, then you can do like that, and you can put it into, for example, another file. You can see script IDs, right, and .txt. Yes, so that thing is here, right? So here you have extracted those transcript IDs in this just one big file. Left, and you can get rid of this thing real quick from here. And where is that replace thing? Do we have replace option in? I've never used that. I think here, yeah, replace with nothing, replace all, and those greater than signs, they are all gone. So your professor will be happy that you did something real quick. I can get rid of this, I can get rid of this, because those two files are saturating my memory. I just want to count how many genes or gene IDs are here. So with grep I can put another option, grep space dash is an option, C means count, right? I'm sorry. So he counted and he put it into this file. So when I go here, my file is then overwritten. So the whole file is gone, so it's replaced by new file. That I don't want it, I just wanted to print it here, right? And I just, also he says 19 genes are there in your big file. Can you give me with the same grep command that how many reads are there in mu1.txt, and reads you can capture with the reads, the individual reads, they start with @ sign. So you can just count how many @ signs are there in this file, mu1.txt. Can you do that for me? I can just wait and see who gets the right answer. Anyone? So what should be the command? Something like grep.
Grep within underscore and at, and then we add the file name.
Excellent, excellent. So what we do is, let me clear that. So grep, right, and within quotes I can write the @ sign. Okay, and yeah, so what's the file name? mu1.txt. It will bring them out. Okay, only those read IDs. I just wanted to count them, so I can do control L, and I just put a small option here, -c. So grep -c means count. Okay, so it says 1000, 1000 read fragments here. So for example, a sequencing company returns you a big file of 3 to 4 GBs, and in Windows you have an option to count it in Microsoft Excel, so or Microsoft Word, and then you do control F thing. In that case it will take really long, because that file, when once it is opened here, you don't need to open a file, but you can just get what you want to do. So that's the power of a programming language. So we counted that we have 1000 read fragments, but in real life you might have 10, 20 millions in just one sample. Okay, all right. So you can go with just grep and see what happens. So it says grep dash dash help. So that means you can get a help file. So you can do just single and h. So that no, it's not working, but you can do dash dash and hel. Grep L and grep C is for count and Z for nulls and B for different options with which you can work with grep. And this grep, if you go into that whole tutorial and practice, and you can just ask Google or any of our forums. So one of our forums is Seek Answers, Seek or SEQ. Seek forum, I guess, or seekanswers.com, where when I started my PhD, it was really helpful. So Seek Answers, yeah, Seek Answers. So Seek Answers forum is where this NGS community is there. So you just post your problem, and they can give you the solution. So maybe I can post that to your class group, right? You might find my own questions, concerns, or queries, or where I try to help someone else. I think, but that should be back in 2014. Since then, I'm now more active on that. So now, being a PI or a professor, I give that stress to my students. So that's what everyone does that. That's what few of you will be doing from few years from now. But those students, obviously, for you, I think it's more fun working with these things. And I think when you are a student, you feel like you have lot many things to do. But I think that is the place where that's where you learn a lot. And I think that was the last time when I learned so many things. Okay, so now right now I'm a manager or a professor or a teacher. I have lot many other things to do, so I don't have the liberty to explore new things. So those students, they are really lucky. Anyways, so here we are. I think since time is limited, but only one command I just want to give you is, have you installed Fastqc? So this, since this format is called as Fastq, the tool is called as Fastqc. Fastq means fast and then QC. QC means quality control. And obviously it should have been Fastq and QC, and then they skipped one Q in between. Then the tool name was Fastqc. My Fastqc is installed. If yours is not installed after Linux, you just do copy. And how can you do paste? Just right click. So Linux will simply paste that. So sudo apt installed Fastqc. I'm not doing, just using Fastqc, and then I'm using this mu1.txt, and he will run and does something, and he says I have completed that. So it will be giving me some graphics or some plots. I can just go back to that folder and just open up those graphics, right? And here they are, right? So what is that? That's the QC of my data. So file name was mu1.txt. Conventional base calls Illumina 1.5, that's the encoding. So he judged that your data is coming from Illumina, from those symbols which are utilized in that QC thing. Total sequences he processed. So basic statistics पास है, वो सबकी पास ही होती है. 1000 sequence flagged as poor quality 0. Sequence length or fragments are of size 100. Their GC content, right? So you take all those sequences and get their base composition, and finally you can go at position number 1, how many A's and T's and G's and C's are there, and then you separate them into how much GC's are there, because as many G's, as many C's, as many A's, as many T's. So that is the 46%. So I think GC content is 46%, depending upon the species. If it's human, it should be around 54, I believe, right? But here it's a plant species, and again, just a small random data set. For viruses, it should be lower than that because viruses are more active. Okay, humans are larger genomes or eukaryotes. Most of their portions are heterochromatin, or most of their portions are introns are non-coding regions, so they don't need to open and close, so we just need to keep them tight. So obviously that GC should be corresponding to which species is this, it should be corresponding to the literature. You remember what this graph is about? So that is where we are seeing those box plots of Q scores, quality scores. So base position number 1 for everybody, this number 1 and number 2 and up till 100. Some of them are just merged or combined, like 12 and 13 put together in one window, 18 to 19 in one window, 24 to 25 are all here, and so on. So and then so they are just averaged across those columns, right? So originally you take those sequences, you take their quality scores, and you traverse these things in like column wise. So first column, if you take that distribution and plot its box plot, it looks like this, right? So maybe I can get rid of this window if possible. If not, it's okay. So the data is good quality up till this point, and when you go towards 5 prime and some of these antennas or some of those reads, overall, all base positions of those reads, that position number 85 onwards, we see in some of them we have the quality scores as low as 2, which is really bad. The individual base positions we are talking about, okay? So how many twos are here, how many ones are here, that thing which we have. So this lower uh, part of that box is Q1, quartile 1, lower 3 4, lower 1/4 of the population. Okay, the lower class has a range from 2 to up till 32. 32 is good, like those ones crossing those these yellow zone or they are in green zone, they are good enough, but the ones in red zones. So what should I do in QC step? I can apply a clipper here, right, or a trimmer here. I would go with trimmer to remove those individual bases and trim that. A clipper will somehow, if all those things are here, all those boxes are here in this zone, we might have decided to clip position number, what is that, 84 onwards or 79 or 80 onwards. So in that case we can apply the clipper tool, but we're not doing that. You look into per sequence style quality, all blue colors, they are all good. What this thing tells, that among the flow cell from where those reads are coming, and that is that information is there within those individual read fragments records. So if you go here, for example, uh, you know, what was that? Click on u1.txt. So if you go here, so that record is here. These coordinates, these positions are telling you from where that read fragment is coming from within the flow cell. Since these are coming from Illumina, so Illumina, that sequencing is done on slide-like things. We call them as flow cells. If you are seeing any colored pattern here, any patches of colors here or here or here, so that means that flow cell might have a noise there, or it might have something uh, like a dust here or something like a broken side. So over there that sequencing quality has been interrupted. A clear blue sign means that all lanes or all clusters within those flow cells, they did well. This one is where you can see their main sequence quality. So here we are taking those individual read fragments and we are averaging them. So there are just 2 or 3 of them that has an average score of 2. Who is this guy? Obviously this guy, B B B B B B B B B, all 2 plus 2 plus 2, 100 times, so that makes 200 divided by 100. So the average is 2. This guy also, the second one, he has also, where is he? Right, so there is 1 to 2 of them that has that read quality is as low as 2, and then you keep on increasing. How many of them has 3? None. 6, some of them, maybe 1, right, but most of them has a average quality of 30 35. So that is the average here. So between 34 and 36 we have 50. This is the 50 out of 1000, but most of them, like 300 or 350, right? So that is 70% amongst them has a quality score of 38. So excellent, right? But few of them are having really bad scores. So we can take those individual reads and maybe we can draw a cutoff here. So anything beneath, for instance, beneath 20, we can just discard those reads, those full reads in QC step. That is where we see their proportion or sequence content, how many A's and how many T's are there. As many A's, as many T's, right? As many G's, as many C's. So those blue and black lines should correspond each other. Those red and green lines should correspond each other. So here we see in the beginning, in the first few base positions, from position number 1 up till 8 or maybe 10 or 12, we see there is very uneven pattern. So again, it's just a small sample, but in real data, if we see that base composition so much, haphazardly peaking, so we might uh, think of taking some decisions on that as well. Down there are the GC content. So for this species, ideally it should be around 47 or 48%. You can look into the literature for Arabidopsis, but here that red line is corresponding that blue line. You can see there are some uneven patterns as well, but he's overall satisfied with the GC content. He's not satisfied by per base sequence content. Where is that? So you can just click, maybe I skip that. Yeah, this one we already covered. Per base and content. Do you want N? You are paying to a company, but at position number 1, 10, is it 10 or 10%? So 10% of the reads, that is 100, around 100 of them has the first base 9 out of, I guess 9%. That's 9, 90 out of 1000 are having N at position number 1. So that we don't like here. So again, he's giving us the warning. But again, as I said, there were total millions of them, like 10 or 12 millions of the reads or fragments were there. I just picked top 1000 just to do these things real quick and show you this analysis. Length distribution. So length distribution should be something like that. We covered that in the document which we made, that word document Galaxy for you. So have you done that QC thing in Galaxy? But in real life we don't use Galaxy, we use the Linux or Ubuntu, and we use the Fastqc. Even this Fastqc is embedded within Galaxy, so over there you just click and it will give you the report. How many are of the fragments of length 99, 0? How many are of the length, I'm sorry, 101? None of them zeros. So we put a dot here, we put a dot here. And how many of them has a length of 100? All of them, all 1000. So we put a bar here, it's a bar chart, and we connect this point. Obviously this one is 1000 or 100%, so that we put a dot here. So we connect these dot with that, these red lines, so that a triangle with a shadowed bar thing represents the like this filter is clear, so sequence length is just fine. Duplication levels, so we just remove one copy of the sequences and we see that again not much duplication. Multiple copies are okay. So how many sequences are in 2 copies? So blue lines is total sequences. So there was just a couple of them that has duplicates, but maybe they may be the real duplicates or PCR duplicates. So we just take one copy out of it to remove those, the ones which are the PCR duplicates. And again, if we are seeing removing one copy, this PCR duplication is a very low probability or frequency of happening, that within a PCR a fragment becomes two fragments and those two fragments go away and then they make their independent clusters. So that sort of monozygotic twinning is very rare. So what we do is we just remove one of their copies. So this thing is called as deduplicated sequences, the red lines, and they are quite smooth. So obviously this filter passes. So there is nothing like no sequence that has been overrepresented. Only some of them, like this card duplicate, this one, and like how many? I guess just 8 or 9 of them, very rare. Again, he's just giving us a little cautious We have adapter content. Is there any adapter at position number one or somewhere in between or in the end? He checked for Illumina, Universal, Illumina, small RNA, next era transposes. He has a dictionary which he consults, and he knows that most of the people are using these adapters. Even you can put your own adapter thing here. You can go into this first and you can put help, and that help file can tell you what you can do with different options, right? Minimum length, no gap, no nano, help, v variant, print the variant of the program and exit, and o out directory. So for example, we just go here and just put one of these options, and it does what it says. So you can look into those in its help file. Right, so I think that's it, pretty it. So if you have any questions, queries or concerns, you may ask myself or anything related to that installation thing. Satya is also here, so she can help you with that. Let us know, we are waiting. Over to you. Anything? Your questions are very important. Anything on
Sir,
the
are the commands which you have taught today, are all of them provided in the folder that you sent to us?
this document, Linux command has everything. grep wali डाल
It would
दे.
be better if we're given like a day to practice.
Satya, you come here. No, no, history save कर लूँ. You come to my place, you save them and share with them, and मेरे ख्याल है मैं ज़रा जल्दी से शाम पाड़ी हूँ. Okay जी, thank you so much. Have fun. See you tomorrow.
Assalamualaikum. So just winding up the session. So whatever we have studied and taught today. So if you wanna save all the commands you have done today. So the command is just the history. Hopefully I am audible to you. And the command is history. If you wanna print it on your terminal, just type history and press enter. All of the commands will be printed on your terminal. So I want to save it in a file. Just call the command that is the history, and for saving it, just directing it to a new file you want to make is a new file that is the history, and name is with history.txt. txt again is the extension we are going to provide, that is the text file. It will be open in the notepad or the Word document. So the command is the history, greater sign. It will direct that you are storing that all of the history commands in a file that is named as the history.txt, and enter. Now you'll be having the history file in your directory. Just type ls and enter, and yeah, here you go. So I'll share these history.txt file in your group. Okay. So any queries and concerns from today's sessions, just let us know. Just post.
Ma'am, I have one question.
Yeah.
Like, sir was mentioning to like press the tab, and my computer was not accepting that, was accepting spacebar. So would there be a difference in the commands? Like, would they vary from like computer to computer, or is it
Yeah.
something else?
Yeah, not exactly, but are you a Mac user or a Windows user?
Windows.
Windows, perfect. Then you will be following this command which we are going to provide you. In case of the Mac users, you have to add the slash sign at the end of the command. But if you are a Windows user, then you don't need to do the slash sign. Plus, you need to follow all of these commands which we have provided in your group.
So we have to write everything without a slash, right?
Yeah, obviously, yeah. That is for
And
the Mac users.
and
Uh,
also, if we have a folder that has a name consisting of two words, let's say, so do we need to add any kind of slash or backforward slash between them?
yes, yes. For reading the folder, having the space in between the two names of that folder, you have to let me do that. If you press the tab, it will automatically cache that and having the forward slash and backward slash between these two names. So it will read the forward slash and the backslash as a space. But it is recommended not to add the space between the file or the folder name which are you are going to read in the Ubuntu terminal. So how we gonna name this? We just enter the underscore between the two names of that file or the folder. Like for example, I wanna save my folder name as the NGS online. So I will name it like NGS underscore and online, like this. Got it? So it is not recommended to add the space between between the two names of the folder. So in case you have the space between the two names, you need to add these forward slash and the reverse slash between it. Mm-hmm. I
Okay,
guess.
thank you, thank you.
Yeah, thank you. So any other queries and concerns? Any other queries and concerns? Uh, just for you. If we have a folder named as the NGS space online, that's what you were talking about. Control L. So, and now we have a folder that is named as NGS space at the online, and I'm gonna go to that folder. So we will just type cd NGS and tab. So it is asking me to which one you wanna go. I'm gonna go to this one. Checking here. Um, yeah, just a minute. Screen. Mm, okay. Yeah, I will close. See how you enter your name with the space having the space in between. So NGS slash space online and again a slash. Perfect now.
Yes, I got it, thanks.
Yeah, perfect. But it is recommended that not to use the space in between the two names of your file or the folder. So hopefully you get the today's
Can you please
session.
send the commands that you have recently said? That would be
Yeah,
very
sure.
helpful if you would
Yeah.
practice it.
Okay. I'll share that history file with you in your group. Sure. Thank you. So if you have any other queries, just do let us know. We are here. We are around. And thank you so much for your patience.